Alright, so this is the most complex version of this that you're going to need to be able to do, so feel free to go through this nice and slowly. Alright, so let's have a look at this reaction here. We're told that K2Cr2O7 it reacts with potassium iodide in acidified solution. Now that means that this is aqueous and this is aqueous, and the acidified solution means that we've got acid particles, which would actually be H3O plus ions. We're just going to keep them as H plus for simplicity's sake. And we're told that the dichromate ion, which is this part here, is reduced to Cr3 plus, and the iodide ion is reduced to I2. And we need to figure out the the half reactions for each of these things, and that will give us the overall balanced equation. Now, before we go anywhere else, what I'm going to do is I'm going to break this up into 2K plus aqueous plus Cr2O7 2 minus aqueous plus K plus aqueous plus I minus aqueous plus H plus aqueous. And what we're going to do is we're just going to ignore for the moment the K pluses, because we know that potassium is always soluble, and so it's not going to form a solid precipitate over here. Now that leaves us with the parts that we're asked in the question. We're asked to deal with the dichromate ion, the iodide ion, and to worry about this. Now the way we're going to do this is we're going to turn the chromium into the chromium and the iodine into the iodine. We're not going to worry about the H plus or the oxygen, and we're certainly not going to worry about the K plus here. Those things will come out by themselves, except for the K plus. We'll just leave that off for the moment. All right. So let's take the easy path first. We've got the two parts. This one turns into that. Let's have a look at that one first. So I've got I minus goes to I2. Okay. Now you can see here that the first thing I'm going to have to do is I'm going to have to put 2 here, because I've got 2 of these and I need 2 of those. Now the overall charge here is negative 2 over here, and it's 0 here. So the way we're going to balance that is by putting 2 electrons on that side there. Now you can see that the overall charge here is the same as the overall charge here, and if we think about iodine, which is in group 7, has an outer shell of 8 electrons there when it's I minus, and to go to I without charge there, it only needs to lose 1 electron, and so it's going to form a single covalent bond sharing 1 electron between them. So each of those 2 electrons, each of the iodines loses 1 electron for a total of 2 electrons lost, and that remaining electron there forms with the other iodine to form a covalent bond to give that structure there. Anyway, all right, so that's our first half equation done. Now we can see that we've gone from -1 to 0 here, and that means that we have been oxidized here. And as oxidized is loss of electrons, this is lost electrons, and the electrons are over here on the product side, so that's correct. We've got the oxidation reaction. Now let's have a look at let's just put a line there. Now let's have a look at the chromium. We've got Cr2O7 2 minus. We don't know what state that's in over there, but we do know that it's going to go to chromium 3 plus. Okay, so I've got 2 chromiums here. I need 2 chromiums here. Now the way we deal with oxygens in this is we don't add oxide ions over here. What we do is we add something that's neutral, water, here. Now with 7 oxygens, I'm going to need to add 7 oxygens here. I've added 7 oxygens. I balance the hydrogens here by putting H pluses over here, and I've got 14 of those, so I just need to move that, pardon me, So I'll move that first because I didn't need the space. Move that out the way. And I balance those with these acid ions here. And this reaction only occurs in acid. It can't occur in a neutral solution. All right, so that's so far so good. I've dealt with the chromiums. I've dealt with the oxygens. I've dealt with the hydrogens that come from dealing with the oxygens. And now I need to look at the overall charge. We can see that on this side here, the tally is -2 plus 14 there, which gives me plus 12 all overall. Over on this side, the tally is plus 6 because I've got 2 times plus 3, and 0 for a total of plus 6. Now, given the fact that we already know that we need to add electrons on this side because they're on the opposite side over there, how many do I need to add to balance this up? I need to take away 6 from the plus 12 to make it equal to plus 6, so I add 6 electrons there. Okay, so now I've got my 2 half equations. Oh, and by the way, this one is my reduction. It's gone. Look, we can figure out the oxidation state in here. We'll do that later. We're not worried about that for the moment. For the moment, we can just say, well, this has been oxidized. The electrons are on the opposite side here, so that one's been reduced. We'll just stick with that for the moment. Let's not do too many things at once. Now, I need to balance the number of electrons here. I can see I've got 2 here and 6 here. I need to make them the same, so I'm going to times this by 3. So that's going to become a 6. That's going to go to a 3. And that's going to go to a 6 there. Now that I've got the 2 half equations done, I can do the overall equation, which is done the same way as before. I'm going to take all of the reactant parts and put them on the reactant side. I'll need a bigger box here because there's a lot of them. And then I'm going to take the product parts, which are all of that, and I'm going to put it on the product side there. Again, I'm going to need a pretty big box. So I've got 6I minus plus Cr2O72 minus. Let's put aqueous there and put aqueous there. Plus 14H plus, which is also aqueous, plus 6 electrons. And this gives me 3I2, which, does it tell us what the state is for I2? Well, I would imagine it would be liquid. Plus 6 electrons, plus 2 Cr3 plus 7 H2O. So far so good. This one has to be aqueous because it's an ion, and it's not. We're not told that it's in solid form. So let's go get rid of things that are the same. So I've got iodine is I minus over here. It's changed, so we keep it. Chromium is in this ion here. Over here, it's changed to something else, so we keep it. H pluses over here don't even exist on this side, so I'm definitely keeping them. The only thing that's the same is the electrons here and here, and so I can get rid of this by saying 6I minus aqueous plus Cr2O72 minus aqueous plus 14H plus aqueous goes to 3I2, call it liquid. Iodine, it might even be solid. Anyway, it doesn't matter, we'll just leave it like that. Plus 2 Cr3 plus aqueous plus 7H2O. Fantastic. Yeah, well, there it is. Okay, so we've got the same amount of charge on both sides, minus 6, minus 8, plus 6 total on this side. 2 times 3 is 6. Charges are the same. And Let's see, is there anything else we want to do with that? Oh yeah, look, that's about it really. We should just go back and do something with the K pluses. Now we can see that here Ki was together, and so we're going to probably have 6 K pluses here, and there were 2 of them with this, so there were six that went with that, 2 that went with that, so we can put the 8 K pluses there, which will be aqueous. And then, of course, because they didn't react, we can put the 8K pluses aqueous on that side. But because they're in the same state with the same quantities and the same charge and everything else, we just ignore them anyway. And so even though we've put them in just for convenience, or for wrapping it up, they do get cancelled out. And that's why it gets ignored in the reaction in the first place when you see examples of this. Anyway, that's it.